I was talking about the distinction between
matrix and vectors.
Yeah, matrix and vectors. And then I said, oh, look at this Coley. She uses this one way to write matrices and vectors. And now, I said, I realized I don't use the same thing as she did, because she used the round brackets for vectors and square brackets for matrices, and I wasn't doing that. For vectors, I'm going to do what?
Bracket and comma.
Yeah, commas. I said I was going to put commas in there for vectors, right? To distinguish between a vector and a matrix. But right here, I didn't do that. I said if we define two vectors, but these are not vectors, at least not according to what I just said. These are what? These are matrices. I'm being sloppy or not correct. So does everyone see that? Because I want to make it reliable so that when you see it a certain way, you know it's a vector. And when you see it another way, you know it's a matrix. And then I just said, if we define two vectors, I made them both matrices. Now, what does this mean here? This thing right here, anybody? Dot product. Dot product is defined for what? Matrices or vectors? It's defined for vectors. Dot product is a vector operation. So that's okay if these are vectors. And I did say they're vectors, but I didn't denote them as vectors. Now, what am I doing all this for? This is x times w, and that's the dot product. So tell me, what is x times w1? What is the dot product of these two? Somebody tell me what that equals. The dot product of this, if this is a vector and this is a vector, what does the dot product give you? So if you have a vector and it has x1, okay, now I'm using this notation, x1 comma x2, so this is a vector according to the way I said I was going to do it. And then if you have the dot product with this, another vector, and what does the dot product mean? What am I going to get from this? What am I going to get here? What is it?
Scalar. X1, W1, X2, W2.
What symbol goes in between?
Plus.
Plus, right? So x2, w2, right? Now, what am I talking about? We're talking about this picture here. We have a node here and a node here. This is x1 and this is x2. And we have another node here and we have a line here and a line here. And this has w1 on it and this has w2 on it. And this is called z, and we put a 2 up here to mean this is in layer 2. So I'll just put that 2 there. That's all that means. It just tells you what layer it's in. So this is in layer 2. This is in layer 1. So we could put actually x1 here. I guess we could do that, but I didn't do that. But you could do that. You could put 1 here to say that these come from the first layer. Okay, anyway, so what is Z2 equal to? Z2 like that. What is that equal to?
X1.
We said that you take this times this plus this times this. This times this plus this times this. So in other words, it's this. Z2 is equal to that. So in other words, Z2 is the dot product of these two vectors. Now suppose I have this, let's call this Z21, and this is another Z2. Let's call it Z2, still in the second layer, so I'll still put that there. But I have to give this a different label. So I'll call this Z22. And then we're going to have, suppose we have some other edges here, like this one, and these have different weights on them. Let's call this W3 and W4. So what is, how do we calculate Z second layer, this one, Z22? What is that? How do I calculate that? How about Mercelin?
Replace W1 and W2 with W3 and W4 in the earlier equation.
Yeah, right. That's right. So it would be X1 W3 plus X2 W4. Right. Okay, now we better find a better way to denote these weights once we run into this kind of situation. Like suppose we have yet another one down here, X3, and we have like another layer here or something, or let's just forget about this. Just suppose we have that, and we have like here, we're going to have a weight here and a weight here. We better figure out some nice way to label these W's. Otherwise, I'm going to have what? W5 here and W6 here, but that's not very helpful. I don't know. What is W6? Like if I just ask you, what does W6 connect? And you didn't see this picture, you wouldn't really have any good way to know what nodes this connects. Like W6 connects X2 to Z3, but you wouldn't really know that just from if I wrote W6. So I should come up with some better way to label these than just 1, 2, 3, 4, 5, 6. So what's another way to give these labels? Instead of W1, W2, W3, W4, W5, W6, what's another way? So I could call this one W6. Instead of using W6, I could do it this way. I could call it W23. And then I could call like this one here, W2. So instead of W2, instead of that, here's W2, I could call it W2. 1. So instead of W6, so this one is going to go for W6, and we're going to use this notation instead. And this one, I'm going to replace this. So what's the notation I'm using? What do I mean by 2, 1? What do I mean by 2, 3? I need some good notation for this. Or what does this mean? W1, 3. What does that mean? Which weight is this going to indicate? So this one indicates what I was previously calling W2. This one is what I was previously calling W6. So what does this one replace?
5.
W5. Why is it W5?
Because it's from 1 to 3. It starts from X1 to Z3.
Yeah. So the notation I'm going to use is this. Wij is going to be what? Where's that going to be? So that's going to come from the ith node and go to the jth node. So this W2, 3 means what? We come from here and we go to 3. So this is where you're coming from and this is where you're going to. Okay, now, what does Z3 equal? Here's Z3. What is Z3? What's the calculation for Z3?
X1 W5 plus X2 W6.
Plus X2 W6. Okay, now use the new notation for the W's. So X1, and then you need a W, and then X2, and you need a W. So what are they?
W13.
1, 3. Okay, W1, 3. And why is it W1, 3?
It's
Because coming from X1 and going to here. That's good. Okay. And how about here? I'm trying to get Z3 here, right? So what is this?
W2.
W2 what?
Oh, 2 and 3.
2, 3. Okay, good. So Z3, how do we get Z3? We take this one, this times the weight that comes from here to go to here. So that's the weight W1, 3, plus this times the weight that goes from here to here. So this X2 times the weight that goes from here, from 2 to 3. So that's W2, 3. Okay, now I want to get a matrix multiplication, and the result I want to be this: Z1, Z2, Z3. And I should put 2's up here, but I don't want to do that. But I'm just talking about these Z's here. It's just too much writing. This pen is awful. So I'm not going to put the 2's up at the top. So I have this. Now I want a matrix multiplication to get that. So the first matrix is going to be the the matrix that contains the x's. So it's going to be like, let's try making this as a, I'm sorry, this shouldn't be a column. This should be a row. Sorry about that. Okay, so I made a mistake. This shouldn't be a column. This should be a row. So it should be x1, x1, x2. Now, what are the what's the dimension of this matrix?
1 by 2.
Okay, this is 1 by 2. And then what does this have to be to get this?
2 by 3.
Wait, is it going to work or not? Yeah, 2 by 3, right. Okay, So if I have a 2, okay, if I have a 2 by 3, and I multiply, if I take the 1 by 2 and multiply it by 2 by 3, I am going to get a 1 by 3. So I know that the middle matrix, this matrix has to be a 2 by 3 in order to get a 1 by 3 at the end. So, and I want to get a 1 by 3 because I want to get the values for Z1, Z2, Z3. Now, how do I construct this so that it works? So that I get the calculation. I saw what the calculations have to be here, and here we did all these. I asked you to do these, and we got this, for example. That's how you get Z3, and I think this was for what? No, that one was for nothing. Anyway, this one was for what? Z2. So we did some of these already. Now I just want to put the right things in here so that when I multiply this times this thing, I get, for Z3, I get this, and for Z2, I get this. So I have to set up this matrix somehow so that this is what I get out. When I multiply this times this, I do get this for Z2, I do get this for Z3. So what does this have to look like here? Remember, what are the weights? How are we labeling them? What's this weight called? W11, right? What's this weight here? How did we relabel this one? That's the one that goes here. How are we relabeling that?
W21.
W21, okay. And how about this orange one? How are we going to relabel that?
W12.
W12. And how about this one? How are we going to relabel this orange one? This one, W4. How are we going to relabel that?
W22.
W22. And how about this one, W6? How's that being relabeled?
23.
2, 3. And how about this one here? W5 is what?
13.
So now we have all these weights, and we know how to get Z1. Okay, let's say, how do we get Z1 again?
X1 W11,
X1 W11 plus
X2
X2
W21.
W21, right? Okay, so we know how to do all these calculations, but I want to do it so that the matrix multiplication gives us that. So I want to get the right thing for Z1, which we know what it is. We just said it has to be that and that. And then the right thing for Z2, so it has to be that, and so on. So I want to do it. Now we see the size has to be 2 by 3. So we're going to have to put in all these weights, but where are they going to go? Well, let's just try for this one. So let's say, how do we get this? It has to be, again, X1, this one, and X2, this one. And that's supposed to give me this. So this goes here. Right, we're going to have this here. So Z1 is what? We know what Z1 is, right? Here. It's this times this and this times this. Now, how about when we multiply, where is it going to come from? Where is this element coming from when we multiply? Well, it has to come from the first row here, because that's all there is. Well, yeah. So it has to come from here. So it's this times what gives me this in terms of multiplication of matrices. This times the first column gives me this, right? Does everyone agree with that?
Yes.
This times this gives me this, right? So what does this have to have in it to make it work for this?
W11.
This has to be W11. And what does this have to have?
W21.
Yeah, and then it's going to work, at least for that first Z element. It's going to work, W21, because when we do this, This is going to be x1 times this, which is what we wanted, x1 times this, and then x2 times this, which is also what we wanted, times that. So that works at least for this element. Now, how about for this element? Well, this is supposed to be Z2. So what's the Z2 calculation?
W12 and W22.
W,
12.
Z2 is W21, sorry, you're right, W12 and W22. So what should be here?
W12.
W1, 2, and what should be here?
W22.
Okay, that sounds good. And then how do we get this element? It's going to come from these, this times these. And what is it supposed to be? Z3 is supposed to be, the weights are what? W23, I'm sorry, W13 and W23. So this must be W13 and W23. Now we've designed this matrix W so that when we multiply it times the input matrix X, we get what we wanted it to give us. Now let's see, what is the pattern here? Can you see the pattern? You know, we got it right, but maybe there's some, you know, sort of, we can notice something about these subscripts. What can we notice about where we placed the W's? Or what can we notice about the subscripts of where we place the W's? So what was this one? What's the subscript? 1, 1. What's the subscript?
1, 2.
1, 2. What's the subscript?
1, 3.
1, 3. What's the subscript? 2, 1. What's the subscript? 2, 2. What's the subscript? 2, 3. So what can we say about the first subscript? What does it tell you?
All are in row 1.
Yeah, the first subscript tells you what row it's in, right? So this first script is 1, it's in row 1. The first subscript here is 1, it's in row 1. The first subscript here is 2, it's in row 2. And what does the second subscript tell us?
Its location in column.
It tells us the column location, right? So now we can write the whole calculation as a matrix calculation. So to get Z1, what do? We take the X matrix times the weight matrix. What do I mean by the weight matrix? This is the weight matrix. So we're going to call this a big W. It's a W. We're going to call it W. It's a whole matrix though. Okay, and we're going to call this X, a whole matrix. And now if we do X times W, we get the whole big Z matrix. So this is a matrix expression of these calculations. So the W is the tricky one. This is pretty straightforward. X, we have to make it a row, not a column. That didn't work. And Z is a row. And then W is this one. And then if we set it up right, then we can express the whole set of calculations as X dot, not dot. This matrix times this matrix gives me this matrix. And that gives me all the z values. So now we can express the whole. Now, we're also going to have some weights here and giving us z, this layer 3z. So we better distinguish between the weights here and the weights here. So we'll call this one W1, capital W1. In other words, here, we'll call this capital W1 to indicate that it's the weights for here, all of these weights. And then we'll call this one capital W2. All right, so now we just talked about how to calculate Z1, Z2, and Z3. All right, now the question is, what is this A? So we haven't talked about that yet. So what are we doing here? How do we get the A's? We didn't say that yet. We didn't explain that yet. So let's find out how that's going to be obtained. So A is, where do we have it here? So here's some R code to calculate. Here's X, W1, W2, and then figure out what Z is. Okay, figure out what Z2 is. So we take this times this gives us Z2. Anyway, that's for the simple case, so let's not worry about that anyway. But anyway, I'll go back to what is A? What is A? Somewhere, I hope I said it. Maybe not. Not yet. Okay, anyway, what A is, so a question is, we had a node and it had a Z 2 here, maybe it was Z2 1 there, maybe we had that node, and then we had another node, and we had another node, but we also have an A here. So it's called A2. So what is that? Well, we didn't say what that is yet. Okay, now I think we already talked about a function that looks like this, didn't we? What's that function called?
Sigmoid function.
Sigmoid. Now, does it go like that? I think it looks like this anyway. So yeah, that was called the sigmoid function. And we used this for it, right? Didn't we talk about that already? Yeah. Okay, it's like an S curve, we said. And we used that, and it's like has a variable. Let's call this variable X. Well, maybe X. So when you put in X, you get out some values, and the shape of the curve looks like this. Right? Didn't we talk about that already? Yes or no?
Professor, you mentioned briefly about it, but not.
Okay. I didn't say that much about it. But this is a curve. It looks like that. And it has a formula, but let's not worry about the formula right now. So if you put in, I hope I have this curve right. Is this right? I think so. Okay, so if you put in 0, actually I have to go back and check. But anyway, all right, let's go back and check. Let's just check quickly. Sigmoid curve. Sigmoid curve. I always forget. Okay, yeah, sorry. It's not. It's centered at 0 actually. Okay, so it doesn't quite look like what I just said. It looks like this. So it looks like this. So it's not. It doesn't start here. It starts way up. It's centered at 0. So it goes up to a height of 1, and when x is 0, the height is 1/2. Okay, so it looks like that actually. Okay, does everyone understand that? So we have a curve like that. It's called sigmoid. And what we do is we just take this value and we're going to put it into sigmoid, and that's what we mean by this A. So if I take sigmoid of Z1, and I guess I should put the 2 here up here. If I have that, that is going to give me A1. And if I do that, let me ignore the superscript. If I do this, Z2, that's what I mean by A2. And what do I mean by A3? I mean put Z3 into sigmoid. That will give you A3. So that's what we mean in this picture by here. The A1, the A2, the A3. How do we get these? We just take this value that we figured out what we mean by that. We do these calculations, we get this value. We put that into sigma, and we get out something. How do we get this A2? We take this value, and we figured out how we're going to get that value. And we put this value into sigma. That's what we mean by A2. And what do we mean by A3? We take this value and put it into sigma, and we get this. Now, the point of this is that it's very important that our function not be linear. Now, sigma is not a linear function. You can see it doesn't look like a line. Okay, but actually, a calculation like this, x1, w1 equals y or equals z, that's a linear function. Doesn't everybody agree that that's linear? Right? If this is the input and this is a coefficient, it's like you have x times 3 equals y. Isn't that a linear function? Right? And even if you have two calculations like this one, we still call it linear in x1 and x2 because it's not like x2 cubed or something like that. And it's not like this to the 4th. There's no subscripts up here, superscripts like that. It's just, this is still called linear. If you don't have anything up here and you don't have anything up here, it's still called linear. So this is obviously linear, and we don't want linear. We don't want this neural network calculation to be just linear. If it is, we're going to have a very tough time predicting things accurately, because linear functions are very restrictive in what they can model. They can only model basically linear relationships, but we don't want to be restricted to only linear relationships. So that's why, as part of our calculation for our neural network, when we go from here to here, we're going to throw in this nonlinear thing, which is in this case happens to be sigma. So we're going to do sigma. Oh, I think we're finished already. Anyway, we're going to do sigma of this gives me this. Sigma of this gives me this. So that's what we need to do. Now, let me just quickly add on that when we go to here, we're just going to take these and multiply them by the corresponding here to get that. So I just mean we're going to take A1 times this, A2 times this, A3 times that, and add them up, and that's going to give me this. And then how are we going to go from here to here? How are we going to go from here to here? We're going to put this into sigma, and that'll give me this. So we're including nonlinear stuff as well as linear stuff. And that allows our function to be much more powerful, much more flexible, also a lot more trouble to deal with mathematically. So it's not so easy to deal with, but it does, it allows us to model a lot more stuff than just a linear would. If we didn't have the sigmoid in here, if we didn't bother to transform this using sigmoid, this whole thing would collapse to just a linear function. And that would be very restrictive. we wouldn't have nearly the kind of success that we do have with using deep learning models. Okay, so by throwing in that nonlinear stuff, that gives us much more power. It also makes it much more of a headache, but still, it gives us more power. Okay, so I have a video of the rest of this, which I want you to watch, and I'll post the location of it. It's basically here, and I'll post the location of it. And so you can finish this chapter, the lecture on this chapter, by watching that. And then you have to do read through the lecture, because I don't really cover any of the coding in the video. Okay, so then you have to go through and read it carefully yourself, but this will give you the roadmap to go through the lecture. I'm sorry, to go through the chapter. And you have to read all the coding.